So now we're going to learn how to do reaction stoichiometry. The good news is this is very similar to the stoichiometry you know how to do already. We're just going to be adding in reactions. So we're going to add our seventh conversion factor that we were not doing in Unit 3. And you'll notice in our seventh conversion factor, if you have your quick guide handy, which you should, there is a B and an A. You'll also notice the word coefficient in brackets. That is because you're going to plug in the coefficients from your balanced equation. So that's why we had to learn balancing before we started reaction stoichiometry. So last thing you might notice is that we don't have the reciprocal of this, okay? The way I do this, and the way we're going to label things, is that we always have B over A. So we don't need the reciprocal. Okay, so let's talk about that factor before we start actually doing stoichiometry problems. So A is going to be the substance in your given, which is what we underline at the beginning of our problem. And B is going to be the substance that you're looking for, which is what we circle. Substance is just chemical. It's the element or the compound. Okay, so substance, element, or compound. So the mole ratio, you might have heard me say before, I've said it as I've walked around the room, that you always have to convert to moles to get to anything else. Okay, that's what we did in our composition stoichiometry. We would take grams and we would convert to moles, and then we would do liters. We just did it all at once. Okay. So now we're going to use the mole ratio, which is moles and moles on the top of the fraction and the bottom of the fraction, to go from one substance to the other. So you'll have moles of A, and then you convert to moles of B. So before we get into an actual problem, let's just write that mole ratio. And we're going to write it as a fraction because then it's easy to just slip into our factor. Okay, so if you're just looking for the mole ratio, write it as a factor. And we're going to put moles of K over moles of H2. And I'm just doing that because that's the order it asks for in the question, okay? If it asked for H2 to K, I would just switch those. And then what you do is you look, okay, here I'm looking for K on the top, so I find K in my balanced equation. And it needs to be exactly as is. So there's a K here, but it's attached to OH, so that's not the K I'm looking for. The K by itself is right here, and it doesn't matter if it's a reactant or a product, we just find it. We then take that 2 and put it here. So the coefficient from the reaction goes into our fraction. And then for H2, we don't have a coefficient, so we know that's a 1. And we put that here. And that's it. That's the mole ratio. That's our new factor. Okay, so all you do is take the coefficients from your balanced equation and put them into your fraction. What you might start to notice here is that if you have not been in the habit of writing your substances, you're going to start to get confused as you go through these, especially once they get harder and harder. It's really important that you don't just write moles and moles. Okay, in composition stoichiometry, it really didn't matter that much because we only had one substance for the whole problem. Now we have 2. And we also have a reaction with other crap in it. So you want to make sure that you are putting the substance there and figuring out what coefficient goes in the right place. So let's do another one. Same reaction. We're going to do moles of KOH to moles of H2O. KOH has a 2, so I'll put a 2 right here. H2O has a 2, so I'll put a 2 right here. And you can simplify that or not. It doesn't matter. Because if you don't simplify it, when you do out your stoichiometry, which is the point of this, it's going to work out in the end. If you do, you'll get the same answer. So it really doesn't matter whether you simplify these mole ratios or not. So that's pretty easy. So let's jump right into a problem. So here, you'll notice it's a little bit longer than the composition stoichiometry ones we did. You'll also have reactions because you need it for those coefficients, okay? But it's the same process. So you're going to start with 25 grams of NH4NO3, and we're looking for mass of H2O. Mass is also grams, okay? What I'd also like you to do at the beginning here is label A and B. It makes it a lot easier if you do that at the very beginning, especially as these get harder and you start to take a long time to do them. You want to have that reference. So A, if you look back at notes we took, is the substance that you're given. It's the one we underlined. So the element or compound that you underlined, that's this right here. So I'm going to put an A above NH4NO3. B is the substance that you circle. So for us here, it's H2O. Okay, so that's the labeling. And it's going to be very helpful if you do that right at the outset. Now that we've done all that, we just go to our quick guide and we follow these steps. Start with what you're given. Write both parts of your units, put your given over 1. We know how to do that. We've done it a million times. So if we start with what we're given, 25 grams of NH4NO3. Okay. Next, use the unicorn diagram to determine the number of factors. That's going to look a little different because before I said you could ignore the A's and B's. Now we have A's and B's, okay? So in this problem, we're going from grams of A to grams of B. So we have to figure out how many factors they are. It's the same process that you would do before, which is why I give you the full diagram at the very beginning of stoichiometry. So we're at grams of A. The only place we can go, the only place that's connected is moles of A, okay? So we have grams of A, that's one factor. Then we go to moles of A, that's two factors. The rainbow is just a fancy line, all right? So it's just like this. You don't count it as a factor. I just tried to make the diagram a little more interesting. So for moles of A, you then go to moles of B. So that's going to be your third factor. And then for moles of B, you can go to grams of B. So that's going to be your fourth factor. So we have a total of 4 factors. So now, step number 3, drop down both parts of your units. So that means you take the grams of NH4NO3 and put it down here. Now again, just like before, not the number. We'll get the numbers at the end. And I'm going to go over how to do this a little bit differently than I did composition stoichiometry. If you know how to do that process, go ahead. I just think this process is just a different way to do the same exact thing that might be helpful for other students. So if you look at the chart, at the steps, it says look to the unicorn diagram to determine the unit on the top of the factor. So this chart, this diagram, not only tells you how many steps, it also tells you units on the top of each factor. So here, grams of A. We have that on our first factor. Now, if we go to the next factor, I put a 2 next to it, moles of A. Okay, so if we go back to our problem, moles, and then A is NH4NO3. So I'm just going to do the top units because that's what the unicorn tells me what to do. The third factor, number 3 over here, is the moles of B. So I'll go to my problem, moles, and then B in my problem, I labeled at the beginning, is H2O. And then here, grams of B, number 4, is going to have grams of B on the top, which you probably already knew because from old stoichiometry, from the first time we did it, you know that whatever we're looking for goes on the top of the last factor. So now we have all our top units, and all we have to do is fill in our bottom units. So just like on the steps, it says to repeat steps 3 and 4 until all of your factors have units. So number 3, drop down both parts of your unit. So we're going to do that. So for this one, we take moles of NH3NO4 and put it down here. And then moles of H2O goes here. So all I did there was take whatever's on the top of one factor and put it on the bottom of the next. Because remember, we're trying to cancel these out. So this goes here and it will cancel. This goes here and it will cancel. All right, so that is just the units. Now we're going to go in and put in the numbers. So same process as before. You take the units you already have and you match them up with one of your conversion factors. So here we have moles on the top, grams on the bottom. If we go to our unicorn diagram and our factors, the one that has moles on top and grams on the bottom is right here. Remember that 1 will go with moles, but molar mass will go with grams. X is molar mass. So I'll put 1 with moles, and then the molar mass is the substance that you have right next to it. So again, having those substances there is going to be very helpful, because if you didn't and you weren't sure if you should be taking NH4NO3 or H2O, or maybe even N2O, that's in the reaction, then you wouldn't know what molar mass to put there. So it's very helpful that when you're labeling things and putting your units on, you're careful about putting both parts of your units. So I know that 80 is the molar mass for NH4NO3. So I'll just throw that right in there. Next factor, I have moles on top and moles on the bottom. So if I go to my conversion factors, moles and moles is this one right here. So all I have to do is put in the coefficients from the reaction. So H2O has a 2 in front of it, so I'll put a 2 right here. NH4NO3 has a 1 in front of it, so I'll put a 1 right here. Last one has grams on top and moles on the bottom. So that's this factor right here. And I do X again, molar mass. However, I do not do the molar mass of NH4NO3. I do the molar mass of whatever the substance is that I have right here. So if I have the correct substance, I know to find the molar mass of water. And then when you solve that out, you get this as your final answer. So same process as what we did before, just adding a few more things. You need to be a little bit more careful about your units and a new, very easy conversion factor. Let's do one more example. So here we have moles of NaClO3, and we're looking for grams of O2. So remember that the substance in your given is A, the substance in what you're looking for is B. So we are going from moles of A to grams of B. So let's go to our unicorn diagram. I'm going to erase what we already have there. So we're going from moles of A in this problem to grams of B. Moles of A will be one factor. We then go over the rainbow to moles of B will be two factors, and grams of B will be three factors. So for this problem, we need three factors. We know this one, the first one, is going to be our given over 1. We also know that whatever unit is on top here, we drop down to the bottom. So moles of NaClO3 goes here. So I'm going to solve this the same way I did the last one, where I just put the top units first, because I already have those ready to go. The first unit, moles of A, we did already. So now our second one, our second factor is going to have moles of B on the top. So moles, and then B in this problem is O2. And then our third factor is going to have grams of B on the top, because that's what our third place was. And then I will just drop down to fill in the bottom unit. So moles of O2 goes down here. So here we have moles on top and moles on the bottom. So to get the numbers that go there, I'll look at my conversion factors. Moles and moles is this one right here, our new one. So I'm just going to plug in the coefficients. So for O2, I have a 3. And for NaClO3, I have a 2. For my last one, I have grams on top and moles on the bottom. And so that's this one right here. So I put the molar mass and 1 with moles. So you only need 1 molar mass in this problem, okay, because we never have grams of NaClO3. So it's really important that you know what molar mass of what. So having this O2 here tells me that I need the molar mass of O2. And now I just solve it. And when you solve that, you get this. So that's reaction stoichiometry, and now we will just practice in class.